All right, everyone, here is the Module 4 Part 2 review you've been working on. Here are the answers. Number 1, what does it mean to isolate the variable? I'll let this be the answer. All right, you got to get it alone. You got to isolate it. You have to get it all by itself on one side of the equation or the other. All right, that's number 1. Number 2, explain the steps involved in solving an equation. Well, a couple of things. Number 1, the goal is to isolate the variable. That's the first thing. How we go about isolating the variable is to use opposite operations. And that means if we're trying to get rid of addition, we use subtraction. If we're trying to get rid of subtraction, we use addition. If we're trying to undo multiplication, we use division. And if we're trying to undo division, we use multiplication. And then lastly, you have to balance the equation. So that's the last thing. Whatever you do to one side, you have to do to the other side. So those are all the steps necessary. All right, number 3, explain what the solution x is greater than 8 represents. Does it represent one number or several numbers? Well, x is greater than 8 means every number bigger than 8, including 8.000001 and so on. So any number greater than 8. Remember when we read the inequality sign, if we're reading it that way, it means this one means greater than because we get to the big part of the sign first. And if we were reading the opposite direction, that would say 8 is less than x. But I would suggest always read from the variable. And in this case, x is greater than 8 is a lot more than one number. It's a lot more than several numbers. It's all numbers greater than 8, which is an infinite amount. Okay? Second learning target. Determine if a given number is a solution for a specific equation or inequality. And what we're going to do here is just solve. We're going to solve the equations. So I'm going to use those steps. So on number 1, I'm going to subtract 1 from both sides. And when I do that, I get 2x equals 6, and then divide each side by 2, and I get x equals 3. That's the first one. These are two-step equations, by the way. Another two-step equation, subtract 3 from both sides. Remember, you have to get rid of the addition and subtraction first. So we get 2z equals 12. And then divide each side by 2, and you get z equals 6. Number 3, I need to get rid of the positive 2 first, so I'll subtract 2 from both sides. And when I do that, I get 3t equals 24. And then divide each side by 3. That's a 3. You get t equals 8. Okay, there's the first 3. Number 4, I'm going to subtract 6 from both sides, and that leaves me with 5p equals 25, and then divide each side by 5, and that leaves you with p equals 5. Okay, number 5, subtract 8 first, and I'll do that to both sides. And that leaves me with 3y equals 0. And then divide each side by 3, and we get y equals 0. And the last one is just a one-step equation. I just need to undo multiplication with division. So I'll divide by 5. Whatever I do to one side, I have to do to the other. And we get g equals 8. Okay, so there's those. It's just solving equations. Undo addition, subtraction first with the opposite operation. Then you undo the multiplication or division with the opposite operation. Isolate the variable. It will tell you what it's equal to. Remember, every one of these you can check. So let me just show you one so you'll remember that you can do this. You can do this on the test. You can actually tell me when you hand it in, Mr. Shankel, I know every one of these. You don't even have to check it. Of course I will, but you could do this. And no, you could know when you hand it in, I got this. So all you do is you take your original equation and you plug in the number that you found for x. So substitute. So I would have 2 times 3 plus 1 equals 7. 2 times 3 is 6 plus 1 equals 7. And then 6 plus 1 is 7 equals 7. And if that's true, then you're right. So I know for a fact that x equals 3 is the right answer. And you could do that for every one of these just to check yourself. I would do that on the test. I mean, that's the time to prove to me you know what you're doing. So why not make sure? Okay, number 7, give 3 possible solutions to the given inequality. You just have to tell me 3 of them, and it could be anything. So x is greater than 2, greater than or equal to 2. I could use 2. That's 1. 3, and 4, 5, 7.5, 10.39. Anything bigger than 2 or equal to 2. Okay, anything less than 5. W is less than 5. Well, I can't use 5 because 5 is not less than 5. But I can go, I could go 4.9. That's less than 5. So is 2. So is -1. Those are all less than 5. Okay. Number 9, f is greater than 0. F is greater than 0. Well, what could f be? Well, it could be 1. Could be 2. Could be 317. Okay. Give me 3. Last one, 10. If you read from left to right, it says 8 is less than or equal to y. Well, that's nice. I don't care about 8. I want to know what y is. So read the other way. Y is greater than or equal to 8. Oh, 8, 9, 10. Okay? All right, let's move on. Learning target, write and solve equations that represent real-world problems. So right here we're solving, and we've got equations again. Let's just make sure we're good at this. I want to isolate the x, so I'm going to subtract 17 from both sides. Subtract 17 from both sides, and I get x equals 8. There's number 1. Number 2, I have subtraction happening, so I'm going to add 11 to both sides. And that gives me y equals 51. There's number 2. Number 3, I have subtraction again, so I'm going to add to undo it. So I'm going to add 33 to both sides. And that gives me k equals 49. All right, there's number 3. Number 4 is multiplication, so I will divide. And that means I'm going to divide both sides by 4. And that gives me k equals, well, 244 divided by 4 is 61. If you don't know that offhand, then do the division. 244 divided by 4. 4 goes into 24 6 times. 6 times 4 is 24. Subtract, you get nothing. Bring down the 4. 4 goes into 4 once. 1 times 4 is 4. Subtract, you get nothing. Done. The answer is 61. Okay, don't get caught and stuck because you don't know what 244 divided by 4 is. Just do the division. Okay, number 5, multiplication is happening, so I'm going to undo that with division. Whatever I do to one side, I have to do it to the other side. And the 5's cancel here, and I get S equals 125 divided by 5 is 25. So there's number 5. And lastly, number 6, this is, I'm going to do it the way it shows now. I will also show you another way that will look familiar because we've talked a lot about these. P divided by 6, I'm going to undo division with multiplication. So whatever I do to one side, I have to do to the other side. I get P equals 13 times 6 is 78. Okay, so 78. Here's what this also looks like. P divided by 6 is P over 6, which we wrote as 1/6 P equals 13. And this is multiplication now, so I'm going to get rid of that with multiply by reciprocal. And if you multiply by reciprocal, you get the 6's to cancel, the 1's cancel, you get P equals 13 times 6, 78. All right? Moving on. Write an equation for the given situation and use it to answer the given question. Kelly bought 5 shirts that each cost the same amount. She spent $35.75. How much did she spend on each shirt? Write and solve an equation to answer the question. All right, so here's what we have. She bought 5 shirts. They all cost the same amount. I don't know how much they were, but that's my variable. It's no big deal. If I don't know, I just make it a variable. And it cost her $35.75. So there's the equation. And then in order to answer it, I just use algebra. Divide each side by 5. And I will get x equals 35.75 divided by 5. That's $7.15. That's number 7. Number 8, Lexi is selling boxes of cookies. The cost of 1 box of cookies is $3. She sold enough to earn... hold on, guys. Hold on. I can't see it. I just noticed that I don't have it. It's not there. Okay, bear with me. I'm going to find it. Okay, I didn't have a copy here in front of me, so I just looked it up on the computer, and I can see now, which all of you have so clearly pointed out. Thank you for all of the help. It's $174. So 174 is what it should say over here, but it got cut off. So how many boxes has Lexi sold? Well, it's $3 for each box. So I know that's the beginning of my equation. And it ends up being $174. So there's my equation. $3 per box is 174. And then to solve it, I'm just going to use algebra and divide 174 by 3. Divide both sides by 3. I get x equals 58 boxes. 58 boxes is the answer. Number 9, Brendan scored 32 goals in his hockey games in January and February. He scored 18 goals in February. How many goals did he score in January? Write and solve the equation. Well, 32 goals in his hockey games in January and February means altogether 32. And he scored 18 goals in February, but we don't know January. So it's January is my variable, plus the 18 he scored in February is equal to his total number of goals, and that's 32. So what we do here is we just subtract both sides by 18. So I can get the variable alone, J, equals 32 minus 18, which is 14. Okay. Good there. Here we go. Moving on. Number 10. Nick had 26 papers on his desk. His teacher gave him some more, and now he has 100. How many papers did his teacher give him? Well, he had 26. His teacher gave him some. I don't know how many. We'll call it P. And now he has 100. So 26 plus P equals 100. And then we just subtract 26 from both sides, and we get P equals 74. All right. Those are looking good. Hopefully you're good on those. Now we're writing an equation with 2 variables to represent a problem and identify how the value of one quantity will affect the value of the second quantity. And this is where we're talking about the independent and the dependent variables. So here we go. Learning target, make a table of possible values. Well, the table's put together for you, so all we have to do is write an equation. So I can do this a couple of ways. I could use the story, but unfortunately there's no story here, so I can't use the story. So I have to use the table. So what I do is I look at the independent variable. And remember, the x value is always independent, the first column. The second column is always dependent. So I look at my independent value, and if that changes by 1, then I know that my dependent variable change is my coefficient. As long as it stays consistent, and it does, it's always a +1. So I know that that is my coefficient. So my equation starts with y equals, it's always the dependent variable equals, I'm going to multiply my independent variable x by 1, so it's just x. And then I might have to add some stuff to this. So if 1 is x, then I have 1 equals 4. But I don't want it to be 4. I don't want it to be 1. Sorry, if I put a 1 in, this 1, in for this x, I get y equals 1, but I don't want it to be 1. I want it to be 4, so I'm going to add 3 to make that happen. And there's my equation. Works with all of the independent variable x's. If I put a 3 in right here, 3 in for x, 3 plus 3 is 6. Yep, the dependent variable 6, so I'm good there. For those of you wondering, the Red Wings beat the Hurricanes 4-3 in overtime. Just got that update. Thought you might want to know. Number 2, again, I don't have the story, but I can just use the table. And well, if I look here, let's see. This is a change of 2, but then I have a change of 3, and here I have a change of 1. So I'm all over the place on my table. Kind of weird. But if I look here, the change is 8. So if I know that the change is twice as big as I want it to be, that means my change in y, this one right here, that's twice as big as I want it to be also. So maybe my equation is, wow, I'm trying to write with circles. Y equals, let me try not to write with circles. Okay, so it's y equals half of 8, because my x varied by more than 1, twice as much as what I wanted it to be. So this varies by twice as much as I want it to be. So I think it's 4x. And if I plug, let me go back to my circles. If I plug that 3 in for that x, then I get 4 times 3 is 12, and that's what I want it to be. So that's cool. If I plug that 5 in, if I put that in there, then I get 4 times 5 is 20, and yeah, that's what I want it to be. So that's my equation. All right, okay, good. Moving on. Number 3, Dunham Sports is selling boxes of baseballs to local schools. The data below shows the total cost for a specific amount of boxes. Use the table to answer the questions below. So easy, man, easy. It's in table form. So I have to find the independent and the dependent variable. First column is independent. Second column is dependent. Automatic. So the dependent variable is the total cost. And you can also check it. Remember, we talked about this in class. Okay? The independent variable determines the dependent variable. So let's see if that's true. Does the number of boxes of baseballs determine the total cost? Yes, of course. And then, does the total cost depend on how many boxes of baseballs I buy? Yes. So I got it. And now I just need an equation. So I'm going to get this out of the way now that I know what's what. And I don't have a story, so I got to figure it out by the table again. And let's see, I've got a change of 4 here. Ooh. This over here, the dependent variable changes by $80. Okay, 80. Well, 4 is 4 times bigger than I want it to be. 4 times bigger than I want. So hold on, bear with me. I'm finding a new color for you. Okay, I don't know. Oregon green sounds good. Oregon green. So look at, if I look at my change in my independent variable, it's 4 times bigger than I want. That means that my coefficient, which is my dependent variable, is 4 times bigger than I want. So 80 divided by 4 is 20. So I'm going to say total cost. Let's call that C, and boxes of baseballs we'll call B. Okay, so the total cost, C, Remember, the equation always starts with the dependent variable equals. So C equals $20 per box. $20 per box. And then I may or may not have to change it. I don't know yet. Let's find out. Let me put a 3 in for B. And if I do that, I get 20 times 3, which is 60. And that's what I wanted. So that's nice. Hopefully that will continue. Let's put a 7 in. 20 times 7 is 140, and that's what we wanted. So beautiful. Looks like we have it. I don't have to add anything to the equation. It is C equals 20B. All right, another one. Another table. Write an equation that describes the... Oh, yeah. Look, we've done so many of these that you should be able to get this now. I know automatically it's y equals, right? Because the dependent variable starts it, so it's that. And then I just check to see how my independent variable changes. Well, that's by 1, so hopefully I only have to just do this. The coefficient is 2. So I know it's 2x. And then I just try it. So let me get back to my red pen. And if I take this 3 and I plug it in for that x, I get a 2 times 3 is 6. But I want it to be 7. Well, I just add 1. So y equals 2x plus 1. It looks like that's what it's going to be. Let's check 4. If I put a 4 in, I get 2 times 4 is 8, but I want it to be 9, so add 1. Yes, that's it. Y equals 2x plus 1 is the equation. Beautiful. Number 5. Here's a story for us. Mitchell is going to an amusement park over spring break. He found out that the park charges $15 for admission and an additional $2 per ride. Write an equation to show the relationship and identify the independent and dependent variables. Love it. Love it. Let's write this one from the story. Okay? The park charges $15 to get in, no matter how many rides he rides. Doesn't matter. He's going to pay $15 no matter what. So I know that, and he pays $2 per ride. What I don't know is how many rides is he going to go on. He might go on none. He might go on 10. Maybe he gets sick after the teacups after one ride, and he doesn't ride any more rides. So, we don't know. So the number of rides is the variable that he gets to choose. So the independent variable is R for the number of rides. The dependent variable is the cost, because the cost depends on whether he gets sick or not, right? So there we go. Independent, dependent. And then I know that it's dependent variable equals, and I can just write it from the story. He pays $2 for every ride, and he still has to pay to get in the park. So the cost is equal to $2 times the number of rides plus 15. C equals 2R plus 15. All right? And then we have to put this on a graph and give ourselves a table. So I'm going to write my equation here. C equals 2R plus 15. Wow, that R, not happy with it. So I'm gonna fix it. 2R, wow. 2R, wow. 2R, that's okay. Plus 15. So the cost equals 2 times the number of rides plus $15 to get into the park. Now remember, when we set up the function table, they gave us x and y, because that's usually the way it is. When you get into algebra, you're going to be talking about line equations. It's always x and y. Remember, the x value goes on the horizontal line, and the y value goes on the vertical. So that's my x and my y. In our case, my independent variable is the number of rides, so I'm going to put the R here, and the cost is the dependent variable, so that goes here. So I'm just changing the table a little bit. Maybe you used x and y's, that's cool, but I'm gonna put it this way. Now, on my x-axis, I need to put, I'm going to try to fit it down here, number of rides. We've got to label that. And on the y-axis, I just have the cost. So that's going there. And then I just choose some independent variables. I can choose whatever I want. I'm gonna make this easy, and I'm gonna go. Let me get a new color. I'm gonna go 0 rides. Okay, if I go on 0 rides, then I'm gonna pay 0 times 2. That's 0 plus 15. I still have to pay to get in the park, so it's $15. If I go on 1 ride, then that's not J rides, that's 1 ride. If I go on 1 ride, I put the 1 in for R, it's 2 times 1 is 2, plus 15, that's 17. 2 rides, well, 2 times 2 is 4, that's here, 2 times 2 is 4, plus 15 is 19. And let's just do 3 rides, 2 times 3 is 6, 6 plus 15, 21. And there is our table. And now we'll just graph it. So let's see, let me just use some black here. I've got to put rides here down on the bottom. So maybe I'll skip every 4th. So there's 0 rides. This would be 1 ride, 2 rides, 3 rides. That fits okay. Maybe I could go 5. I do want to split it out as far as I can. 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So I've got 0, 1, 2, and 3. I'll just put it here so you can see them because I don't have room down there. 0, 1, 2, and 3. That's the number of rides. And then my cost goes from $15 up to $21. So I'm going to do the same thing. I'm going to skip by 1, 2, 3, 4, 5, maybe 6. 1, 2, 3, 4, 5, 6. There's another one. 1, 2, 3, 4, 5, 6. There's another one. And 1, 2, 3, 4, 5, 6. There's my last one. So this is $15. This is $17. This is $19, and this would be $21 up here. And I might even say, hey, the cost is in dollars, just to make sure. And then we just graph it. If he rides 0 rides, it's $15. If he rides 1 ride, it is $17. That's there, there, there. 2 rides is $19. So 2 up here at 19. That's there. And then 3 rides is $21, and that's somewhere in there. Okay, so there it is. And then, do we draw an arrow or not? Well, can we ride a half a ride? Well, I guess if you get sick and you can, you can talk them into stopping the ride, or perhaps when you throw up, it sprays into the operator's eyes, causing him to hit the safe. I don't know. I think the answer is no. You cannot. You're going to ride 1 ride, 2 rides, 3 rides, 4 rides, not fractions of rides. So no arrow on this one, just the dots. And there you have it. Good luck. Your test is Wednesday. Watch the video again. Study on IXL. Practice, practice, practice. Hope that helps. See you next time.